So for this question, complete the table of values to find the rate of change. I want to remind you of the definition of rate of change. And what rate of change is when you have a graph and you are trying to compare the y value. So if it's a straight line between the two coordinates, you want to be able to compare the y values between the two, so that you're comparing basically the rise, and you're comparing the run between the x values. That is the rate of change. And when we are looking at a straight line, that can be equivalent to a slope, right? And so we're dealing with some linear examples, lines. So what they're saying is that you're trying to find the first difference. What the first difference by definition is, that the first difference, you're taking the difference in the y values. So that's y2 minus y1. So let me highlight this for a sec. So first difference is y2 minus y1, whereas rate of change is y2 minus y1 divided by x2 minus x1, meaning what was if this is the rise, that's the run, right? So the difference kind of is that, well, right now, if you notice, take a look at the x values and notice how it's going up by 1 in each case. That means that's why they're generalizing and say, okay, well, the rate of change is the first difference, okay? But I want you to take a second, pause the video if you need to, and take a look at this. What we usually do when we are given a table of values is that first check that the x values are going up in the same amount. If they are, sometimes we find the first difference, which is a difference in the y values, to double check whether it is going up in a constant rate. So what I'm going to do is do 13 minus 10, that is equal to 3. 10 minus 7, which is equal to 3. 7 minus 4, which is equal to 3. 4 minus 1 is equal to 3. 1 minus minus 2 is equal to 3. So what's going on is that generally, as the x values are going up, you are having some consistent patterns. You are starting at -2, but now you're at 1, and then you're at 4. So see how I'm starting to make a line, right? So we have just verified that the first differences are constant. So first difference are constant, or the same. So what is the relationship between the rate of change and the slope? Well, what we can say is that, first off, that the rate of change, and if they're defining it as first difference, the first difference are the same. And because, we'll just write it down, rate of change is equal to 3 versus slope. Well, slope, we know that we compare two coordinates. And if I use any of the coordinates here, like the first two, because it's smaller in value, that's like doing 1 minus minus 2 divided by 1 minus 0. That's equal to 3 over 1, which is equal to 3. So notice how the values are exactly the same. The reason that works out is, well, because the differences, like the x values are going up by the same amount and exactly by 1. So when you're doing that dividing step, you're dividing 3 by 1. And so you can just say that the rate of change is equal to 3. And more precisely in this example, it's the first difference that is equal to the slope. And so right now you can say that the rate of change is equal to the slope. So I'll just say rate of change equals slope. Okay. And I kind of already had that from the start. So what is the slope? Well, the slope is m equals 3. What is a y-intercept? Well, if I was to sketch this briefly, that means that at 0, my y value is -2. And at 1, my value is 1. I'm just going to draw that part. I can tell right away that the y-intercept, I'll just highlight using green, that if that's the y-intercept is right there. So the y-intercept is at 0, -2. Write the equation of the line that models this linear system. So through this process, we found that the first difference is 3. It also divides by a difference of 1 because it's going up by 1. So all in all, we're concluding that the slope is 3. So because, well, this is the since, it's like the backwards therefore, since m is equal to 3 and b is equal to negative 2, therefore y is equal to 3x minus 2 is the equation of the line. It is the equation of the linear system.